welcome to our second episode of the Hitchhiker's Guide to the Industrial Metaverse. I'm extremely happy to have today a guest, Ishika Roy from NVIDIA. Welcome again, Ishika. We've met in a project at BMW where we did the factoryverse integration of NVIDIA Omniverse and a proof of concept with QOpt, the revolutionary optimization tool, I'd say. Ishika, welcome, and you're calling from India right now. So maybe if you tell a little something about you as well.
Yeah, so it was great collaborating with you guys over BMW and ipolog's effort that we had last GTC. So I'm excited to join this talk today and kind of share what we have already done and what we are looking forward to doing further with ipolog.
Thank you. Thanks so much for joining. So I hope the weather is better in India as in Germany. Probably you've got nice, right?
Not really.
Oh.
And summers are really, really hot.
Okay. So yeah. So thanks again for joining. Today, this episode is about reality layers. I've called it. We're visiting different sorts of layers of reality, which are basically a real essential part of the industrial metaverse, as I'd say. So last talk, I've can I show my screen right now? Maybe how do I do that? Let's see. Now you should see my screen, right? Yes. So if you look into like the industrial metaverse and compared to the also what I say social metaverse, we don't have only the reality which we all share, which is synchronous and runs in real time. We have different layers of reality. So and this time I'd like to share a little and visit these different reality layers I'm talking about. So the first layer, I call it observed reality. That's what we get in our digital factory twin from scanning, from sensors, which we get the current state of our environment. That's important for the to have a good starting point for our planning, and this is the second reality layer, the planned reality, because every organization has a plan what it wants to do and when, and so we have to take care of this current and future state which we have planned. So if everything runs accordingly as we have planned, reality should look like this. And also we can track this with the observed reality and see if our observed reality follows our plan, basically, and if our plan was correct. So and based on these observations, we update our plans, and so this industrial metaverse kind of digital twin has to take into account, or be able to take into account, our plans, what we got right now, and also exchange it. Plans in the factory are basically projects. So we have different projects running all in our organization, and we have to be able to interweave all our plannings into one holistic planned reality. And there's also where alternative reality comes in, because every project needs to have different planning scenarios, which we can base our decisions on. this is what I call alternative reality layers, because for this interval in time as our project goes, we have to be able to simulate all elements of our planning context to really take into account every other project as well and other planned state to make us to enable us to take the right decisions, right? So we look into alternative A and say, okay, maybe that works out, but we choose to take the other scenario here, and so we basically need an environment to take into account all these different layers of reality. And Ishika will tell also about this alternative reality layer, which we use different tools like QOpt or simulation or other things to create these simulations of alternative reality to base our decisions on it. But let's say at the observed reality first. I'd like to, as I said last time, we go into more hands-on examples. So how can we bring the observed reality into our digital twin? And I'd like to give you 4 examples. The first is from Navis, a company we also work with, which uses laser scanning and their devices. I hope you see it. Do you see it? Yes, yes. So this is an example they did with BMW, and which is also a customer of ipolog. So they it's a little blurry, but you can imagine. They walk basically with these kind of devices around the factory and scan it. And there is a laser scanner on it and some cameras, and so they create basically from the whole factory like a digital scan. So we have at this point in time, as you see here, the state of the environment, and these guys they create panoramic images. And have a viewer which you can use like Google Street View. Basically, you see here is an example from their demo site. It's their office building. I can walk around or look around basically and change the panoramic stations. But more important for us, we got a good view on it, but we want to have the 3D point cloud information, and we can show that here. We can see there is not only panoramic image, but also points as a point cloud, and this is what we use in our full 3D digital twin. Get this observed reality layer. Here you see the points, right? And to give you an example how that works, I've here started my Omniverse viewer, and as you can see here, some artifacts. I think when I'm still here, you don't see it, but here's an example of this point cloud data set of a pipe, for example. So we've got all these different points, and as I go zoom in, you see, it's just points. So we might, for some use cases, this is sufficient. We can measure. But for other use cases, we need like a nicer representation, like the rest of our environment, right? And so we get to the second company. It's called they're called Preview 3D. They take the point cloud and create a mesh out of it. So like a triangular shape, which is textured, and also they segment the elements in order to integrate these scans. They also support Navis data sets to have a real 3D environment to navigate in. Here we get a little example. You see, we've got the meshes, and what you see here, you can also segment the meshes and pull them out, move them. And this is exactly what I've done. They also have an Omniverse connector. So I've also used that, and sorry for the movement here. It's screen capturing is a little, but I think you see it, right? So here's this element is from Preview 3D. So it looks like a normal resource, right? But if we go in and zoom in a little more, we see it's from it's remeshed from a point cloud, basically, right? So this is the second example, and to bring in the reality layers, as I told, and relatively new. And if you have questions, just write them into the chat, please. So we try to answer them. What NVIDIA Labs recently released is a representation, not point cloud, not meshes, but neural radiance fields, NERVs, it's called. And I think this is a very promising technology to bring in this current observed reality into this holistic digital twin. There is an example here, and I give you a short example as well. You can download this already from NVIDIA. So here the paper, it's quite new development. So they presented it 2020, I guess. And so it takes basically a few images and trains a neural network in order to create images for new viewpoints. So I can quickly show that to you. Is it? There we go. And I've just downloaded the example, so I haven't done too much with it yet, but I just wanted to show how it works. We have this training environment, and we have here the data. Here images of these guys. So they use like these images of a fox, like how many? A few. And we take this and throw it into our nerve trainer. So and it takes the images and trains the neural net. And while it's training, we can look at it and see that see that the error becomes less and less and less. And as you see, I can regenerate viewpoints from any angle, and this is an example. We could also remesh it, but very promising in my point of view. I don't know what you guys think about it, but so that's the third way of bringing the reality into our digital twin. And also we have IoT signals. So we have a resource state, which is recorded or monitored or coming in from the resources in the factory. And I want to give you also an example of that. I've created a little sample here. Where is it? Just a sec. There we got it. Here's our device. Here a forklift, right? In our factory, and we want to map the current fork position, which is transmitted with MQTT to our digital twin. And in order to do that, I've created a little script in Jupyter, because I don't have the real hardware here. I have created a little script which creates like MQTT signals and translates them and sends them to the MQTT server. So just a sec. Where is it? It doesn't want to. But I think no, doesn't want to. So never mind. We also already are a little too. What does it do? Oh yeah. No. That's strange. So yeah, I think we skip on that, and you can watch it in this link I've supplied it. Let's see how it works. Just to give you an idea. Yeah, you've got like this slider, and it just moves the fork. Pity. That's demo effect probably. It's it should move it like that, right? So yeah. Well, never mind. So these are the different ways of bringing in the observed reality state, and to go to the planned reality. We might have different projects in the factory to combine together. And let me load that really quick. Tell that. So given we've got maybe two projects, and we have to integrate these two projects into one digital scenario, twin scenario. And I'm just loading this. So I've added, and I'm using here the USD layering approach, because we can, as I told last time, we can add different elements, and here these are projects as layers in this global namespace. So here you see, I hope on the right, I've got a project A, which deals with this machine. We want to move it here to this place, right? And we have another project which deals with this rack, and we want to move that rack basically here, right? So and now that we've got our common digital twin, we can see that there are constraints from the place, right? So we can't move this element when this rack is still standing here. So that's why we basically created also time information, and so here we can basically make sure that our projects work as expected, because we have the 3D representation at all time. And yeah, I think this is also a nice aspect of using UST. And as you said, or as I said, this is just 2 projects, and we in order to make a better decision, we have to have alternative reality layers. And here is where Ishika comes in, because she has with QOpt, for example, a very powerful tool to create different alternative realities, and we can pick then the reality we choose best for our project. But Ishika, I'll hand it over to you.
Yeah, thanks, Michael. That was great, and it's great for NVIDIA to be able to collaborate and contribute to all of this. So thanks for that. So I know we've discussed a lot of exciting things, and I'm here to introduce the idea of a third aspect in this industrial metaverse, and that's the alternate reality, which enables us to optimize layouts or make real-time design decisions. And to talk about that, I have a small video. So if we could just bring that up. Yeah, so to conceptualize what dynamic design decisions would look like in an alternate layout of the factory, I'm taking the example of this small area where all the assembly of different parts onto the base structure actually takes place. So in this current scenario, we can see a lot of AMRs and forklifts going around, and their task is to pick up these parts from all the storage locations and then take them to the designated machines for pre-processing. And once the parts are processed into the finished product that we want, that is ready to be assembled, these AMRs just take them to the destination assembly point. So if we try to take a look at a very simplified version or a bird's view version of the layout and the routes that we have right now, this is kind of what it looks like. So we have our bots on the left in the station or the depot from where they are dispatched, and one needs to take part A to machine A and then to the first assembly point, and part B to machine B to our second assembly point. So we can see with our current layout, these are kind of the optimized routes that were taken by the 2 transport vehicles. But now we want to see if there exists an alternate reality or an alternate layout, if that could optimize this even further to save costs and resources. Like, what if we move machine A to a slightly different location? And what if we move our station to a more centralized location in the factory, which is more accessible? So we can then use QOP to recalculate the whole cost and routes almost instantaneously to verify if this decision was indeed a good decision. And looking at the routes and the cost generated right now, we can then eventually alter the factory design and potentially in the long term save up a lot. And of course, this was just a small example, and we can extrapolate that into a much larger environment. And we have already successfully done that with ipolog and BMW in the last GTC, and we had a significant reduction in cost, about 25% in the number of vehicles. That's a significant number, right? And the best part is that we are continuously evolving and improving the efficiency and accuracy. So you can use QOpt right now to get started on Omniverse, or a new update is that we have QOpt as a managed service coming soon if you want to sign up for the early access. So it's always great as a team sharing all these exciting new updates that we have. And we hope everyone experiences and gets the opportunity to take advantage of co-op's GPU acceleration to optimize their operations with ipolog.
Thank you. So awesome for this demo. And I think you also have a new world record for optimizers. If you like to share that, maybe.
Yeah, so all of the information about new world records and everything is directly available at the site. So if you just want to take a look, just go to the co-op website, and all of the world records and all of the information will be available there.
Yeah, so that's awesome, and yeah, they can like make use of all the, if you have lots of GPUs around, them, right? So
and it becomes much easier once it's like a hosted managed service. So you just log on and use co-op. It's as easy as that.
Yeah, that's we use that as well, and it's really nice and easy to use. So everybody try it out, and also it's coming on the cloud, and everybody can download it basically, right? So that's gonna be cool. So times just flies. I think thanks a lot for presenting QOpt and this alternative reality layers. I'd open it up for questions. If anybody has questions, remarks, please write them to the chat. We'll maybe able to take one or two, but
I see one question where I think Richard is asking if there's a way to switch between alternate realities or the layouts. So the concept here is that we will provide tools where you can create those different layouts dynamically and use co-op to almost instantaneously find out all the possible route and the costs that you will incur. And you can select basically which, depending on the different criterias, which layout suits your design optimizations the best.
And also I might add with it depends if you want to compare, for example, the different scenarios. You can also use USD layering to or referencing in this context to compare the different scenarios or bring in the live situation as well, and so there are different possibilities on that, we've created the SyncTwin app as well as an kit extension or based on NVIDIA Omniverse, which enables you to bring in, for example, also project management data, but this will be another live cast, I'd say. One more question, maybe. I think we're almost out of time. But if you have any more questions, please reach out to us. Send us a message. Let us know on our channels. Ishika is also on the different channels, and just try it for yourself, I'd say. And so once again, thank you, Ishika, for joining. It was a great pleasure and very informative. I'd also like to thank Bia, our moderator in the background, and her colleague Janine, and also Alex Fender from NVIDIA for organizing things. So thanks a lot, and thanks again, everybody, and especially Ishika. see you some other time maybe, and you have a great day, all you together. Thank you.
Thank you.